Hello and welcome to Engineers Mindset Academy. So today we'll begin the very first series in thermodynamics, which is the introduction to thermodynamics. Now, before going deep into thermodynamics, we are going to be laying some basic foundation, and which is the essence of this video. Now, the basic foundations we are going to be laying in thermodynamics include the meaning of thermodynamics itself, thermodynamic systems and types, thermodynamic properties and classifications, thermodynamic energy and types, thermodynamic states and rule, thermodynamic process and classifications, work, heat and sign convention. So these are the basic foundations that will guide us through our journey in thermodynamics. So let's start with the very first one. What is the meaning of thermodynamics? Thermodynamics is actually a branch of engineering science which deals with the study of the properties of matter as they are being affected by changes in temperature. It is simply the branch of engineering science which deals with the study of the property of matter as they are being affected by changes in temperature. The word thermodynamics is actually a compound word involving therme and dynamics. Okay, involving therme and dynamic is actually a compound word where therme actually means heat. Therme means heat and dynamics means the action of force. Dynamics simply means the action of force. So if you join these two words together, or these compound words together, you can also define thermodynamics as simply the action of the force of heat. It can also be defined simply as the action of the force of heat. Now, like I said, going deep into thermodynamics, we need to understand what a thermodynamic system is. So that will bring us to the second thing we are going to be talking about in thermodynamics, or the second foundation, which is thermodynamic system. What is a thermodynamic system? A thermodynamic system is simply a fixed quantity of matter in space whose behavior is under investigation. It is simply a fixed quantity of matter in space whose behavior is under investigation. Now, two keywords that you need to pick out from there are: one, it is a fixed quantity of matter, and secondly, the behavior is under investigation. These are two keywords. Now, what is a fixed quantity of matter? When we talk about fixed quantity of matter, we are simply talking about a fluid. So it can be a water or any form of fluid at all. Then again, if the behavior is not under investigation, then it is not a thermodynamic system. Now, I'm going to give a real example of what a thermodynamic system is. Let's say you have a cup containing hot water and you intend to make tea out of this cup. Now you bring in your chocolate, you bring in your milk, and you bring in your sugar and pour all of them into this cup of water. If you don't stir it, what happens is this tea content will go to the bottom of the cup and settle. And if you try to taste the water, or the liquid content in this case, it still tastes like a pure water or a natural water, regardless of the fact that we have mixtures of sea contents inside of it. But when you pick up your teaspoon and you stir the cup and mix all of them together, you are now running an investigation to know if the tea is sweet or it is not sweet. Now, in that process where you are stirring the cup, you are undergoing an investigation. In that case, you can simply call a tea cup to be what? A good example of a thermodynamic state. Now, you have a fixed quantity of matter, which is the water enclosed in that cup. Then, after pouring your tea contents, what do? You stir. You are now investigating. So, if the quantity of matter is not under investigation, then it is not a thermodynamic system. Now, let's say we have the tea cup as explained earlier. So we have our cup. Okay, forgive me, the diagram might not be too perfect, but let's say this is our cup and we have the fixed quantity of matter, of course, which is now the water present in the cup. Now, if you pay attention to that definition, it says a fixed quantity of matter. So which means the quantity of matter is actually fixed in a particular region. Okay, the quantity of matter is fixed in a particular region. That is why it said a fixed quantity of matter. Since it is fixed, then we can simply call, like we said, this is now the system itself. The fixed quantity of matter is called the system. That is the liquid content inside the cup, which is under investigation. Now, since it is isolated or it is fixed, confined in a particular region, now inside a cup, in this case, okay, inside a cup, then the cup is simply called a boundary. This cup is called a boundary. So whenever we talk about thermodynamic system, then we must always talk about a boundary because it is fixed. The system is fixed. And what is helping the system to be fixed is called the boundary. So the system is enclosed or trapped in a boundary. Now, what is a boundary? A boundary is a separation between a thermodynamic system and its surrounding. A boundary is the separation between a thermodynamic system and its surroundings. So as can be seen on the board, you see that the system is a quantity of matter or the T inside this teacup, okay, and the separation is simply called the boundary. This is what helps the teacup, this is what helps the tea not to be spilled to the surrounding or not to be exposed per se to the surrounding. Now, another word which we have said is the word surrounding. The boundary is the separation between the system and the surrounding. So, which means we have another word there called surrounding. Surrounding can be defined as everything outside the boundary of a system which is affected by what is happening inside the system. Everything outside the boundary of a system which is affected by what is happening inside the system is called a surrounding. For instance, if let's say the teacup contains a hot water, you agree with me that if you bring your hands closer to this cup without directly touching the cup, you feel the heat or the warmness from the teacup. You feel it outside on your hand. Okay, so which means the air particles around that teacup is being affected by what is happening inside the teacup. So that is simply called what? A surrounding. Surroundings are simply everything outside the boundary of a system which is being affected by what is taking place in the system. So in this teacup now, we can simply have something like this, and we call this atmosphere around. We simply call it surround. So there is no system without a boundary. There is no system without a surrounding. So in essence, you can simply draw something like a cycle, and you have a fixed quantity of matter inside the cycle. This is called a system, whereas the separation itself is simply called a boundary. Okay, this is called a boundary. The separation is called a boundary, and every other thing outside the boundary, okay, are simply called the surrounding of the system. We simply call this the surrounding of the system. So there is no system without a boundary, there is no system without a surrounding. And again, if the behavior of the quantity of matter is not under investigation, then it is not a system. Now, we are still on system. If we take a look at we've talked about the boundary, we've talked about the system, then we have types of system. So we are going to be picking each of them and explaining them. Now, apart from definition of the system, we have types of system. There are basically two types of system. We have the open system and we have the closed system. Okay, we have the open system and we have the closed system. What is an open system? A system is said to be an open system when the quantity of matter under investigation, in addition to energy in the form of heat and work, can cross the boundary between the system and the surrounding. A system is said to be an open system when the quantity of matter under investigation, in addition to energy in the form of heat and work, can cross the boundary between the system and the surrounding. Now, for example, let's say we have a reservoir containing water. Let's say we have a reservoir containing water, and we have an opening or a valve in this reservoir. Let's say we have an opening, something like a tap. Okay, let's say we have an opening in this reservoir containing water. Okay, something like this. All right, let's say we have a reservoir containing water. All right, so you have something like this. Now, if this valve is open, what happens is that water flows out of this system, okay? If the valve is open, water flows out of the system. So this is a good example of what an open system is. A system in which the quantity of matter present can cross the boundary between the system and the surrounding. Now, the reservoir itself, this is the boundary. The reservoir itself is simply called the boundary. The quantity of matter itself is called the system, and of course we have the surrounding. Now the boundary is always attached to the surrounding because it's always exposed to the surrounding. So if the quantity of matter can cross the boundary between the system and the surrounding, then this is called an open system. Whereas a closed system is simply a system in which the quantity of matter which is under investigation cannot cross the boundary between the system and the surrounding. Only energy in the form of heat and work can cross the boundary. Okay, a closed system is simply a system in which the quantity of matter which is under investigation cannot cross the boundary between the system and its surrounding. Only energy in the form of heat and work can cross the boundary. So in that case, we simply say if this valve is short, okay, if the valve is short, if the valve is short, in this case, the quantity of matter cannot cross the boundary between the system and the surrounding. Or simply, if there was no valve at all, let's say we just have the reservoir in this manner and there is no opening, then we simply call this a closed system because the quantity of matter is still enclosed. Now, the only thing exchanging between the surrounding and the boundary is simply energy in the form of heat and work. And this is because this energy in the form of heat and work cannot be seen. So constantly, they cross the boundary between the system and the surrounding. Okay, so that is it about the types of system. Now, there's a special type of system called isolated system. It is a special type of a closed system, okay? There is a special type of a closed system called isolated system. An isolated system is simply a system which does not even interact both heat to the surrounding. It doesn't interact heat to the surrounding, that is, it doesn't exchange heat with the surrounding. It doesn't also exchange the quantity of matter with the surrounding. So that is why it is called a special type of a closed system, but it is not really a type of a system. Generally, we have just two types of systems, the open systems and the closed systems, whereas the isolated system is simply a special type of the closed system because it also has to do with non-exchange between the system and the surrounding. Now, in the case of the isolated system, heat is also trapped. Heat cannot cross the boundary between the system and the surrounding. That is why it is simply called an isolated system. It is simply isolated from the surrounding. Having talked about the types of system, let's move over to the boundary now. We've said that the boundary always provides restriction to the given quantity of matter in a system. Now we have four types of boundary. We have the real boundary, we have the imaginary boundary, we have the fixed boundary, and we have the movable boundary. So I will explain the four of them in details. So let's start with the first one, the real boundary. What is a real boundary? A boundary is said to be a real boundary if it can be seen, felt, or touched. A boundary is said to be a real boundary if it can be seen, felt, or touched. Example is the boundary of a teacup or the cup itself. Of course, the cup is simply the boundary. So example could be a teacup. The cup itself is simply what? A boundary. You can touch it, you can feel it, you can see it. So it's simply called a real boundary. Now let's talk about the second one, which is the imaginary boundary. An imaginary boundary is simply a boundary that cannot be seen, felt, or touched. A boundary that cannot be seen, felt, or touched is called an imaginary boundary. Now, I'm going to show you a footage, okay, of a boiling water in a kettle. Now, notice or observe the steam that comes out of the kettle. Notice that this steam follows a particular direction, a particular guide or trajectory when coming out from the mouth of the kettle. The steam follows a particular trajectory, and this trajectory cannot be seen, but they follow a regular pattern before they escape into the atmosphere. Okay, that pattern, that trajectory covering that steam, enveloping that steam in that manner before it finally disappears into the atmosphere is called a boundary because it is restricting the steam from immediately disappearing into the atmosphere, but rather they follow that particular pattern, and after some distances, then they can start disappearing into the atmosphere. That boundary is called an imaginary boundary. Since it cannot be seen, it cannot be felt, and it cannot be touched, but you can observe that there is something happening there that is making this steam to follow this particular pattern before disappearing into the atmosphere. That is simply called an imaginary boundary. The third type of boundary is what we call the fixed boundary. Just like the name implies, fixed. It means the quantity of matter under investigation is fixed in a particular position inside this boundary. It is non-movable. Okay, a good example is your tap. Okay, the tap in your either your bathroom or your backyard or your kitchen. Now notice that this tap is fixed in one position. Okay, the tap in the bathroom is fixed in one position and it cannot move. So I'm just going to show a footage now. It cannot move. Okay, so since it cannot move, then it is said to be a fixed boundary. That tap remains there. Water comes in and goes out if the valve is open or closed. Now, such a boundary which is not movable and made to be in one position or a static position is simply called a fixed boundary. The final type of boundary is called the movable boundary. A movable boundary is simply a boundary that can change position, just like the name implies, movable. It is simply a boundary that can change position. Now, you agree with me that most of the tap we have in our kitchen sink, we can move them about. So you can turn the tap to one direction, you can turn the tap to the other direction. So we simply say that such a boundary is what? A movable boundary, since it can change position from place to place. It is simply called a movable boundary. So that brings us to the whole package on a thermodynamic system. We've talked about system, and I said we have two types of system: the open system and the closed system. Then we have a special type of a closed system which is called the isolated system. Then we talked about the boundary as the separation between the system and the surrounding, and we mentioned four types of boundary. We have the real boundary, the imaginary boundary, the fixed boundary, and the movable boundary. And of course, we talked about the surrounding to be everything outside the boundary of a system which is being affected by what is happening inside of the system. Now, having done with the system and the types of system, let's move to the third thing we have today, which is the thermodynamic properties and classifications. What are thermodynamic properties? Thermodynamic properties are simply the characteristics features of a system which defines the state of a system at a given point in time. Okay, they are simply the characteristic features of a system which identifies or defines the state of a system. Examples include pressure, volume, or temperature as the case may be. So if you're given, for instance, the pressure of a fluid is initially 10 bar at a temperature of 15 degrees Celsius. In that case, you're defining the properties of that system at a given state within a given time. So that is simply called what? The thermodynamic properties. Now, thermodynamic properties can be classified in two ways. Thermodynamic properties can be classified in two ways. First, according to their variability with mass. According to their variability with mass. Now, under this classification, we have two types of properties. We have what is called the intensive property and the extensive property. Okay, we have the intensive property and the extensive property. Intensive properties are those properties which do not depend on the quantity of matter of a given thermodynamic system. Intensive properties are those properties which do not depend on the quantity of matter of a given thermodynamic system. Examples of intensive properties are pressure and temperature. So in general, we are simply saying intensive properties are those properties which are not mass dependent. They don't depend on mass to be what? Found. Example include pressure and temperature. Whereas extensive properties are those properties which depend on the fixed quantity of matter enclosed in a system. Okay, extensive properties are those properties that depend on the quantity of matter in a system. So in general, we are simply saying they are those properties that depend on the quantity of mass, or they are those properties that depend on mass of a system. So we have what is called the volume, we have the energy, internal energy, entropy, heat energy, and all of that. These are good examples of extensive properties because they actually depend on mass. Now, since the extensive properties depend on mass, we usually divide the total value of these properties by what? Mass. And when we divide the extensive properties by mass, we have what is called a specific property. Now, I said that the example of extensive properties include examples like volume, we have the volume, we have the internal energy, okay, we have the internal energy, okay, we have the entropy, we have the specific heat capacity and all of that. Now, we said these are all extensive properties. Now, when we divide the extensive property by mass, we have what is called specific property. So, for instance, specific properties, okay, the specific property of volume, the specific property of volume is now going to be, okay, take note, we use small letters to represent specific properties. We'll make use of small letters to represent specific properties, and we said specific properties are simply extensive properties divided by mass. So it means that specific property of volume can be represented with what? Small letter v for volume, and this is simply what? The total volume, which is the extensive property, capital V all over mass. Okay, so when we divide the capital or the extensive property by mass, we have what is called the specific property. So small v is equal to capital V all over m for mass. So this means in order to obtain the total volume or the extensive property of volume, which is capital V, we simply cross multiply and multiply small v, which is now the specific property of volume, by mass. So total property or extensive property is simply what? Small v times mass m. So we have specific volume times mass, that gives us the total volume. Now in terms of internal energy, okay, internal energy is symbolized by the letter U. So specific internal energy simply becomes small u, and this is going to be what? Total internal energy all over mass. So this simply means in order to find total internal energy, which is the capital U, we have to what? Multiply always the internal energy or the specific internal energy always by mass. This gives us what? The total specific total internal energy, and this gives us the total volume itself. All right, so like I said, extensive properties are those properties that depend on the quantity of matter. So in general, we simply say that they depend on what? Mass. And examples are volume, internal energy, entropy, specific heat capacity, and so on. All right, and then I talked about the specific properties. When we divide the extensive property by mass, we have what is called the specific properties. When we divide the extensive property by mass, we have the specific property. So which means that whenever a problem is given to you and it is always expressed in, let's say, a meter cube per kilogram, that is a specific property of volume, because meter cube there stands for unit of volume. Now per kilogram means that volume has now been divided by what? Kilogram. So this simply means that in case of volume, specific property of volume is always what? A meter cube per kilogram, because meter cube is unit of volume where kilogram is unit of mass. Now, dividing the two of them makes this what? A specific property. So in order to obtain total volume, we have to multiply the specific volume by what? Mass. All right, so in order to obtain always total properties, always multiply the specific properties by mass. It will give you the total properties. Okay, so that's the first way of classifying a thermodynamic property, okay, by variability with mass. All right, the second way is by the ability to directly measure them. Second way is by the ability to directly measure them. And under this, we have what is called the primitive properties and the derived properties. So we are going to be talking about this in a separate video, and it is not for this video, but just keep it in mind. Two ways of classifying thermodynamic properties. First, by their variability with mass, and secondly, by the ability to directly measure them. All right, so that will be the end of the thermodynamic properties. Now let's move over to thermodynamic energy and types. Now, what is a thermodynamic energy? Thermodynamic energy can be defined as the extensive property of a system which determines the capability of the system to change the state of the system by interaction between the boundary and the surrounding. It can be defined as the extensive property of a system which determines the capability of the system to change the state of the system by interaction between the boundary and the surrounding of the system. In a thermodynamic system, we have two types of energy. We have the enthalpy and we have the internal energy. In thermodynamic system, we have two types of system. We have the enthalpy and we have the internal energy. Enthalpy symbolized by H, and we have the internal energy. Okay, internal energy. The internal energy symbolized by U. All right. So we have the enthalpy and we have the internal energy symbolized by U. So don't forget it, everything we'll be talking so far have been centered around the thermodynamic system. Now let's fall back to the thermodynamic system. We said we have two types of system, the open system and the closed system. And we define the open system, or let's start with the closed system. We define the closed system as that system in which the quantity of matter under investigation cannot cross the boundary between the system and the surrounding, but only energy in the form of heat and work may cross the boundary. So the quantity of matter is fixed. This brings us to the idea, if the quantity of matter is fixed, then what is the energy present inside the system? The energy present inside a system is simply called internal energy. The energy present inside a system is simply called internal energy, and that is the energy usually found in a closed system. So every closed system has what is called internal energy. Whereas we talked about the open system and we said the open system is simply a system in which the quantity of matter under investigation, in addition to energy in the form of heat and work, may cross the boundary of the system and its surrounding. Okay, now in that case, two things happen. First of all, the system is the quantity of matter is present in the boundary. So which means always every system contains an internal energy. Always, whether closed or whether open, every system contains an internal energy. But when in a case of an open system, when the fluid begins to cross the boundary between the surrounding and the system, there's a different type of energy taking place there. And that type of energy is called the flow energy. Okay, that type of energy is simply called the flow energy. That is the energy which guides or assists, or the energy which causes the fluid to flow out of the boundary between the system and the surrounding. It is simply called the flow energy or the flow work. It can also be called the flow work, and this flow work is simply given mathematically as pressure times volume. That is the pressure in the fluid times the volume of the fluid. That's simply called the flow work. Whereas the internal energy is the energy always enclosed in a system. So even if it is an open system, there is always internal energy. The energy present inside the system is called internal energy. Whereas for an open system, as the fluid is flowing out, it exhibits an energy which helps it to flow out of the boundary. That energy is called the flow work or the flow energy. Now, the open system exhibits these two types of energy, both the internal energy and the flow work. The sum of the internal energy and the flow work is what is called enthalpy. So enthalpy H is simply the sum of internal energy U plus flow work, which is pressure times volume. So mathematically, this can be written for enthalpy, the sum of internal energy and flow work. And the enthalpy is majorly seen in an open system. The enthalpy is majorly seen in an open system because the open system involves two types of what? Energy, internal energy and the flow work. So the sum of the two is simply called enthalpy. So keep this mathematical relationship in check, because as we are going to be going deep into thermodynamics or further discussions, we are going to be needing all of these formulas for calculations. All right, so that gives us, or that brings us to the end of thermodynamic energy and types. Okay, the next thing to talk about is what is called the thermodynamic state and the rule to define a thermodynamic state. What is a thermodynamic state? A thermodynamic state is a condition of a system at a given point in time. A thermodynamic state is the condition of a system at a given point in time. For instance, let's say fluid was initially at a pressure of 10 bar and temperature of 15 degrees Celsius. That is the condition of the state at that point in time. Okay, that is the condition of the state at that point in time. The condition of a system at a given point in time is called the thermodynamic state, and we simply use state 1 or state 2 to describe what this state. Okay, just like explained, let's say okay, just like explained, we said the pressure P1, initial pressure is simply 10 bar, and T1 initial temperature is simply what? 15 degrees Celsius. So this is what? State 1. This is called what? State 1, which means the initial state of the system. So if there is a change in state and then we'll have a new state, let's say state 2, let's say upon increase in temperature to 30 degrees Celsius, the pressure increases to 20 bars. In that case, we'll have another condition which is called state 2. Okay, upon increase in temperature to 30 degrees Celsius, that is T2, which is state 2. The pressure becomes 20 bar, that is P2 at state 2. So that becomes another condition of what? The thermodynamic system. So the condition of a system at a given point in time is what we call what? The thermodynamic state. All right, now the thermodynamic state can be defined or can be identified using what is called the two property rule. The thermodynamic state can be identified using the two property rule. Now, what is the two property rule? The two property rule simply states that the state of a thermodynamic system in equilibrium can be identified by two independent intensive properties. These two independent intensive properties are called specific and extensive properties. Okay, these two independent intensive properties are called specific and extensive properties. So that is what the two property rule is simply talking about. The state of a system in equilibrium can be identified by two independent intensive properties. Okay, these two properties are simply called specific extensive properties. Okay, so that brings us to the end of thermodynamic state, and we move on to thermodynamic processes and classifications. What are thermodynamic processes? A process is any activity within the system which causes the thermodynamic states to change. A process is any activity within the system which causes the thermodynamic states to change. So whenever we have a change in state from initial to final state, then we said a process has taken place. Now earlier in the example I gave for a state, I said if a fluid is initially at a pressure of 10 bar and temperature 15 degrees Celsius. Now let's say that this fluid increases in temperature to 30 degrees Celsius. So T2 now is equal to 30 degrees Celsius. The pressure also increases. P2 is equal to, okay, to 20 bar. Now this becomes what? A new state. Call this state 2. Okay, this becomes a new state. Call that state 2. All right. This activity that causes this thermodynamic property or this thermodynamic system to change from state 1 to state 2 is we simply say a process has taken place. When a thermodynamic state changes or a system changes from state 1 to state 2 by any activity at all, it can be increase in temperature, it can be reduction of temperature, it can be increase in pressure, whatever activity that causes a thermodynamic state to change from initial state to final state, or even from initial state to intermediate state and to final state, then we simply say a process has what? Taken place. So a process is simply any activity within a system which causes the state of the system to change. Now, there are three ways to classify a process. There are basically three ways to classify a process. First is by the type of system involved. First is by the type of system involved. Secondly, a process can be classified by the relationship between the initial states and the final states. Secondly, a process can be classified by the relationship between the initial state and the final state. And lastly, a process can be classified as reversible or irreversible process. A process can be classified as reversible or irreversible process. So let's pick them one after the other. Let's start from the first. The first way a process can be classified is by the type of system involved. So if we have an open system, then we have what is called a flow process. But if we have a closed system, we have what is called a non-flow process. All right, so let's make out some space on the board and explain what that means. All right, so we said that an open system is simply a system which allows the quantity of matter to flow in and out of the system. So matter can simply flow. It can go out of the system or it can also come into the system. That is simply called an open system. And I gave a vivid illustration of the tap. I will still show a footage of it now. Okay, the tap in your bathroom or your kitchen or whatever, whenever you turn on the valve, water starts flowing out. That's a good example of an open system when the valve is open. So like we said, you can classify a thermodynamic process by first the type of system. So if the system is an open system, then we'll have quantity of matter flowing in and out of the system. That is simply called a flow process. So such a process is called a flow process. So we'll have this to be the system, and we said a system can be either open. So if the system is an open system, then we'll have the process to be what? A flow process. Okay, something like this. We have the system to be a flow process simply because the system is open. Hence, the process is, in that case, is called a flow process. But if the system is a closed system, it means that the quantity of matter cannot cross the boundary between the system and the surrounding. So whenever you shut the valve of a tap water, what happens is you completely turn off the water and water cannot flow anymore. In that case, the process is called a non-flow process because water cannot flow out of the system anymore. It is simply called a non-flow process. So if we have a closed system, okay, if we have a closed system, then the process is simply non-flow process. All right, the process is simply a non-flow process. So that's the first classification of a thermodynamic process by the type of system involved. And under this, we have the flow process and we have the non-flow process. Now, just before we move on, it is also important for you to know that the open systems are also called control volumes. Just keep that in mind. The open systems are also called control volumes, whereas the closed systems are called control mass. The open systems are called control volumes, whereas the closed systems are called control mass. And when we use their names interchangeably like that, instead of saying open and closed system, and we are saying open and we are saying control volume and control mass, then the boundary is called a control surface. Then the boundary is called a control surface. So when we don't use the word open system and closed system, rather we use the control volume and control mass, then the boundary of the system is called a control surface. All right, so just keep that somewhere in mind. Okay, so let's fall back to the second classification of a thermodynamic process. We said a thermodynamic process can be classified by the relationship between the initial and the final state. Okay, they can be classified by the relationship between the initial and the final state. Now, what does this mean? If the initial state and the final state are the same, then we have what is called a cyclic process. That is to say, the process has gone on a cycle. If the initial state and the final state are the same, we have what is called a cyclic process. But if the initial state and the final state are not the same, then we'll have what is called a non-cyclic process. So that simply means that if at initial condition pressure is 10 bar and at the final condition pressure is also 10 bar. At the initial condition temperature is 15 degrees Celsius and at the final condition temperature is also 15 degrees Celsius. In that case, we say that the process has gone through a cycle. So that is simply called a cyclic process. But if the initial state and the final state are not the same, just like explained here, in this case, state 1, pressure is 10 bar, but at state 2, pressure is 20 bar. At state 1, temperature is 15 degrees Celsius. At state 2, temperature is 30 degrees Celsius. It means that the initial state is not the same thing as the final state. In that case, then we say the process is what? A non-cyclic process. The process is simply a non-cyclic process. Finally, we said the third way to classify a process is either as a reversible process or irreversible process. A reversible process is a process in which the final state can be brought back to its initial state by doing the exact opposite of what was done in the forward process without a residue of energy. I will take it again. A reversible process is simply a process in which the final state can be brought back to its initial state by doing the exact opposite of what was done in the initial process without a residue of energy. So if I can drive my car some distances forward and drive the car the same distances following the same path backward, then and I still have my fuel restored or my petrol restored back into my car, then I will simply say the process is what? A reversible process. But we know that in real life there is no such thing as reversible process. If I drive my car forward, I've exhausted petrol. If I still drive the car following that same path backward, the petrol can never come back. I will instead lose more petrol. So there is no such process as reversible process. If I burn a wood today, it turns into a shaft. It can never be brought back into what? Wood. It's no longer possible. So there's no such process in real life as reversible process. The other one is the irreversible process. Of course, the name is already clear. An irreversible process is simply a process which cannot be reversed. An irreversible process is simply a process which cannot be reversed, and that is the nature of all processes in real life. There is no process that can be reversed. The only process that can be reversed, I think, is between maybe your ice block and water. Of course, once you bring out the ice block and keep it, after a while the ice turns back into water. If you put the water back into the freezer, it turns back to ice, and so on. So I think that's the only process that can be reversed and all of that. But in real life, there is no such thing as a reversible process. But then that is it on classification of processes and thermodynamic process itself. The final thing we're going to be talking about is work, heat, and sign conventions. Now, what is work in thermodynamics? In thermodynamics, work can be defined as the transient form of energy which is found at the boundary between a system and its surrounding by virtue of pressure difference. In thermodynamics, work can be defined as the transient form of energy which is found at the boundary between a system and its surrounding by virtue of pressure difference. Mathematically, work can be defined mathematically in thermodynamics. Work can be defined as integral from initial volume V1 to final volume V2 of pressure times change in volume. Okay, this is a mathematical relationship of work in thermodynamics. Integral from V1 to V2, P times change in volume, or P dV. So we said that work is a transient form of energy. When we say transient, we simply mean that it cannot be seen, but it is existing. So it is unseen, but yet it is what is happening. It is actually it is actually going through or happening in the system. So that's why it is called transient. And mathematically, we use that formula to solve any problem requiring us to find the work done of any function in a thermodynamic system. Okay, so let's move on to heat. Heat can also be defined as a transient form of energy which is found at the boundary between a system and its surrounding by virtue of temperature difference. By virtue of temperature difference, it is a transient form of energy found at the boundary between a system and its surrounding by virtue of temperature difference. So notice the difference between the two of them. Work is by virtue of pressure difference, whereas heat is by virtue of temperature difference. Now, you cannot solve any problem involving work done in thermodynamics without knowledge of some sign conventions, very important sign conventions which we need. Okay, so different textbooks have different sign conventions which governs them in calculating work done in thermodynamics. Okay, so I have my own sign conventions, and of course, different textbooks have their different sign conventions. If you're going to be following my teaching, then you're going to be following my own sign conventions. Now, what are these sign conventions? The first sign convention is when heat is added to a system, it is positive. But when heat is removed from a system, it is negative. When heat is added to a system, it is positive. But when heat is removed from a system, it is negative. That's the first sign convention. The second sign convention is when a system undergoes expansion, then work done is positive. But when a system undergoes compression, then work done is negative. I'll take it again. When a system undergoes expansion, then work done is positive. But when a system undergoes compression, then work done is negative. The third sign convention is when work is done on a system by the surrounding, that work is negative. But when work is done on the surrounding by the system, then that work is positive. When work is done on the system by the surrounding, then that work is negative. But when work is done on the surrounding by the system, then that work is positive. Okay, so that brings us to the end of the introduction to thermodynamics. All right, so in the next video, we can now apply this formula and these sign conventions which are given to start solving problems involving work done in thermodynamics. Please do well to like this video. I'm sure you like the video already. do well to tap the like button. And of course, if you have any questions at all, make it very interactive. You can post your questions in the comment section, and I promise to respond to all your questions. Or you can also come to my DM on WhatsApp. My number is displaying on your screen. You can come to my DM on WhatsApp if you have any problem at all in thermodynamics, and we can chit chat. Also, if you're new to the channel, please, I also plead with you to subscribe the button. I also plead with you to please tap the subscribe button and turn on the notification bell to continuously get updates when other videos drop. I will see you in the next video. Thanks and cheers.